So I'm going to explain about my project, Intelligent Examination Submission Frameworks. Um, so this is the agenda of the project. Introduction, statement of the problem, scope of the project, which contain functional scope, technical scope, institutional scope, out of scope components. So the methodologies we are going to propose is architectural diagram, flow diagram, algorithm used or design use case diagram, class diagram, important code signals. So next, outputs and results, the test case, conclusion, future references. Introduction. The rapid transformation of education institution has significantly modernized the teaching, learning, and assessment process. However, despite these advancements, many institutions continue to rely on physical action for written examination due to regular requirements, infrastructure limitations, or academic policies. The transition from physical examination scripts to digital grading environment present a critical operation challenge. These challenges increase exponentially with a large student population and high examination. The problems are risk, manual effort, human errors, security risk, lack of simplification. So staff must individually scan, rename, verify, and upload hundreds of answer steps, resulting in executive workload. The human errors, incorrect file naming, wrong assignment of notes, or misattributed student submission can compromise grading accuracy. Security risk, direct bulk uploads or data manipulation can break the chain of custody and introduce unauthorized access. The scope of the project is functional scope, technical scope, institutional scope. Functional scope, this system supports bulk upload of scanned physical answer scripts by authorized examination step. So technical scope is the project is implemented as a middleware system using secure web technologies and REST APIs. Unsynchronized processing and uh, independent transaction ensure reliability and scalability. Institutional scope. The system is applicable to universities and colleges conducting written examinations. So the framework is suitable for internal exam and semester exams. So out of scope components, assumption and constraints. So automated grading or evaluating attitude is not included in this project. Uh, Direct modification of LMS scope functionality or grading logic is output of the scope. So assumption and constraints. So the elements APIs are available and properly configured during submission. Stable network connectivity is assumed for authentication and LMS interaction. The methodology which we are used here are answer script digestion, secure bulk upload by staff, the metadata extraction validation, secure staging and storage, student authentication. So student applications are students logging in using their official LMS credential through the middleware system. Authentication ensures secure and student specific across to ancestors. So student verification. Student verification and preview. Student authorized submission. The LMS integration and final submission. Audit logging and status tracking. The student verification preview follows. Students preview their scanned answer scripts before submission. This step ensures correctness and elimination of submission activity. So this is the architecture staff portal, student portal. So through staff portal, we have to authorize and upload. So student portal, we have to submit and Google Claim. Next, course grid storage SQL, file storage. Design use case diagram. Design use case diagram. Staff to it. Through staff, we have to log in and upload papers. So view papers, submit elements. A sequence diagram, staff API database. Algorithms which we are used here are bulk upload of answer sheets, validation database extraction, secure tagging, and state assessment. So examination staffs can scan physically answer sheets and upload them if invalid files are rejected during the initial stage. So validation metadata extraction, the system validates file naming conventions and file integrity. Hardware and software selection. So the required hardware for Intel i5, 8 GB minimum storage, storage 256 256 GB SSD, so network 1 GB per second. Software which we record on Python 3.10 version, fast AP plus UniCon, Most to get attention is fuel.